This will be the last video on distributive property. In the first example, our factor on the outside is another variable. However, we're going to apply distributive property like we've been doing thus far. We're going to multiply the variable x to each term within the parentheses. So we have x times y is going to give us x, y, and then x times a positive 3 is going to give us plus 3x. Now notice I didn't write this as x times 3 or x3, and that's because 3 represents the coefficient of x, and we always write that in front of the variable. And because this is 3 times x, or x times 3, we can apply commutative property and change the order, making x3 to 3x. Let's look at another example that might look a little strange. Here we have x minus 2 in parentheses, and to the right of it we're multiplying another term, in this case a variable. This problem is the same as this. The only difference is the order is reversed. Again, with commutative property, you could rewrite this as y times the quantity of x minus 2, or you could just multiply this y to each term within the parentheses. Take note that this is a negative 2. So I'm going to write this as x times y minus 2y. Now I do want to point out that I didn't write yx. When we're writing the multiplication or the product of variables, we're going to write them alphabetically. So x comes before y, and that's why it's written as x times y or xy. Also, I didn't write it as y times negative 2. Again, like this last problem, the coefficient is going to come before the variable. Okay, let's do a few problems with negative factors. In this example, we have a negative 2 times the quantity of x plus 3. In previous problems, the factor that we were multiplying to each term was a positive number. We're now working with a negative number. So we're going to multiply this negative 2 to x and positive 3. And this x happens to be a positive x. Now when we're multiplying positives with negatives, our answer is going to be a negative. So negative 2 times a positive x is going to give us a negative 2x. And a negative 2 times a positive 3 will give us a negative 6. Now we could change this, if you choose to do so, to negative 2x plus negative 6. But either way is correct. Let's look at another example. Here we have a negative times the quantity of x plus 5. Notice we do not have a number associated with this negative symbol. When you see a minus sign in front of, or a negative sign in front of the parentheses, you can assume that this is negative 1. Now when we multiply, we're going to multiply negative 1 to a positive x and to a positive 5. So negative 1 times a positive x is going to give us a negative x. Again, I don't write a 1 or a negative 1x. It's just going to be negative x. Negative times a positive is a negative, and 1 times 5 is 5. So negative x minus 5. And again, if you want to change this to an addition problem, you can. It would look like this. Negative x plus negative 5. Let's do another one like that, but with a subtraction problem within the parentheses. Here we have negative 3 times the quantity of x minus 3. We have a negative factor, and we're going to multiply that to a positive x and a negative 3. So negative 3 times x is negative 3x. Negative times a negative is a positive. 3 times 3 is 9. Now let's do some simplification. In this example, we have 9 minus 3 times the quantity of x plus 2. If we think of order of operations, we know that multiplication happens before subtraction. So think of this problem here as a multiplication problem. We're going to apply distributive property first, and then we'll use commutative property to move things around and then simplify. So I'm going to go ahead and rewrite the 9, and this negative or minus 3 is going to become negative 3 times x times positive 2. So that's a negative 3x minus 6. Remember, a negative times a positive is a negative. Okay, now I have two types of terms in this expression. I have constants, a positive 9 and a negative 6, and I have a variable with a coefficient. I'm going to go ahead and move things around. I'm going to put my negative 3x first. Then I'm going to write out what I have left. I have plus 9, because this is a positive 9, and minus 6. 9 minus 6 is 3, so my simplified expression is negative 3x plus 3. Let's look at another problem like this. In this example, we have 8 times the quantity of x minus 1 minus x plus 5. So we're going to apply distributive property to break up these, or to get rid of these parentheses. And we're actually going to do distributive property on the second part as well. Let me show you. So in this one, we have 8 times x gives me 8x times 8, and then 8 times a negative 1 is going to give me minus 8. Now, with this second part, this is like having negative 1 times a positive x plus a positive 5. So a negative times a positive is going to give me a negative x, and a negative 1 times a positive 5 gives me a negative 5. Now I want to combine like terms. I have two terms that have x value or variables in them with the same exponent, which is 1. So this will combine with that, and these constants can be combined as well. If I write it out, I have 8x minus x minus 8 minus 5. This becomes 7x because 8 minus 1 is 7. And I know that when I'm subtracting, I could change this to negative 8 plus negative 5. So if you want to write it out like this, change it to an addition problem. That becomes two negatives added together. That's going to give you 7x minus 13. Okay, we're adding two negatives.